As we continue on to learn about triangle congruence, we've got a couple more shortcuts we're going to learn, and they're pretty easy to figure out just by looking at their acronyms. We are going to apply the angle, side, angle, angle, side, and hypotenuse leg to construct triangles and to solve problems. We're also going to work on proving triangles congruent by using those postulates. So the only new word we're going to learn, which is similar to one we learned earlier, is the included side. So if you remember, the included angle was the angle in the middle or created by the two sides that were congruent. Well, included side is the common side of two consecutive angles in a polygon. The following postulate uses the idea of an included side. So when we talk about angle, side, angle, notice S is in the middle, means we're going to have sides that are included, or in between our two angles. So that's kind of a picture. PQ is included in angle P and angle Q. So like I was saying, angle, side, angle, this is the big thing we need here. If two angles and the included side of one triangle are congruent to two angles and an included side of another, then the triangles are congruent. So if we have angle, side, angle, and it matches angle, side, angle, then we can prove the triangles are congruent. We don't have to do the other two sides or the third angle. So now we're going to try a couple using angle, side, angle, where S is in the middle. Notice that that's going to help us in our letters. Pay attention to those. S in the middle. We are going to determine if we can use angle, side, angle to prove the triangles congruent. So let's look in this picture. We see we have two sets of angles. This one angle is congruent to this one, and this side is congruent, or this angle is congruent to this angle. The only other information we have is anytime we said the two triangles are touching, they have a side that is congruent because of the reflexive property. It's the same side is a part of both triangles. So we do have two sets of angles and a side. Now we want to check, is the side that we're given in between or included in the two angles? And I would say no. The included side would be these outside ones, this long one and this long one. We don't know those. So if we don't have the included side, we'd say angle, side, angle cannot be used to prove the triangle is congruent. Maybe there's something else that does, but it asked if we could use angle, side, angle, so we're going to say no. Alright, let's try another one. It says, determine if we can use angle, side, angle to prove triangle NKL, this top one, to LMN, the bottom one. Well, the only information we're given is that they have a set of parallel lines. And so a couple times we've talked about if we are given parallel lines, there's certain things we want to look for. We want to look for a transversal. So the only transversal in the picture, or line that goes through the two parallels that is a part of both triangles, or gives us stuff that's a part of both triangles, is this line NL. So if you kind of picture this transversal extending through the two lines, we have two parallel lines cut by a transversal, and I see some angle pairs from that. The most specific one I see are alternate interiors. Notice this top left one, well, I guess it'd be the top right up here of this triangle, is alternate interior to this bottom left one of the bottom triangle. So these are alternate interiors, so we know angle KLN, this one right here, is congruent to MNL because they're alternate interiors. Well, the only other thing we have, if I want to find other pieces that are congruent, I do see again that the triangles are sharing a side. So by reflexive, NL from this triangle is congruent to NL from this triangle. So we have a set of sides and a set of angles, but do we have any other angles? We don't. So we cannot say that the triangles are congruent because we don't have enough information from that. So one way to prove triangles congruent, angle, side, angle, the sides in the middle. We can also use the third angle theorem to prove another congruence relationship based on the angle, side, angle, the angle, angle, side. So notice we can still have two angles and a side, and the side not be included. So it says if two angles and their non-included side of one triangle are congruent to the two angles and a non-included side of another, then we can say the triangles are congruent. So notice J and G, side JG would be included, but they chose one that's out here. Notice they still have to match. It's really important when we do angle side especially to make sure that they are corresponding. We want to make sure their pieces match before we can say that triangles are congruent. Okay, now we're going to look at a couple example proofs. This one says, given G is congruent to K, they show us that in the picture, J is congruent to M with the two dashes or two arches, and HJ is congruent to LM. Given that information, we would want to prove that the triangles are congruent. So remember, I've always told you to always start with the givens, and that's what's always our first step. So if we say that G is congruent to K and J is congruent to M, well, the reason we knew that is because it's listed up here with the word given. Remember, our prove is not part of the given, but everything up here, I can write the reason is given. Now the next one says we are using the third angles theorem. Well, if we remember back, the third angles theorem says if I have two angles from one triangle that are congruent to two angles of another triangle, then both triangles' third angles must be congruent to each other. So notice that is the situation I have here. G and K is one set, J and M is another. So both those triangles' third angles, H and L, should be congruent. So we have H is congruent to L because of the third angle theorem. Now the next one also says given. So if I look back at the given statement, notice I used the first two pieces, but I did not use the third yet. So for that next given, I'm going to write HJ. So the only other thing I need to fill in, why are our two triangles congruent? So a lot of times if we add the symbols into the picture, it makes it easier for us to find out this last reason of why the triangles are congruent. I have two angles and I have two sides. Now I need to decide, is the side that I'm giving included in the two angles or not? Well, I see that it is up here on the outside. It's not between the two angles, I know. So I don't want S in the middle. So I'm going to call that angle side. That's the reason our triangles are congruent. All right, we're going to look at one other one. The hypotenuse leg congruence theorem says if the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So even though there's only two letters here, there's still three things that we need to know to have triangles congruent. Not just any triangle have a hypotenuse or legs. So we first of all need our triangles to be right triangles. And if we do have right triangles, to prove those congruent, both their hypotenuses need to be congruent, and then one set of their legs must be congruent for the triangles to then be congruent. Okay, we're going to look at an example. Determine if we can use hypotenuse leg congruence theorem to prove the triangles are congruent. If not, tell what else we would need to know. In our picture, the first thing we said we need to check, are they right triangles? Well, if this is a right angle and that's a straight line, then yes, we have two right triangles. And I see that they are sharing a leg because they're touching right here. So we have the leg part of the hypotenuse leg. Now if we look at the hypotenuses, they both have a dash on it, which means that they are congruent. So we do have a set of hypotenuses congruent. And since we have a right triangle with a set of hypotenuses, hypotenusi, and legs congruent, then yes, the triangles are congruent by HL. Okay, how about in this one? If I'm looking at the two outside triangles, we do have that they're right triangles. We do have that a set of their sides is congruent, but if we look for hypotenuse, it doesn't tell us anything about hypotenuse. They could be the same, they kind of look the same, but if it doesn't tell us that, then we don't assume. So by looking at this diagram, we don't have enough information to say that yes, they are congruent. Okay, here's another one, might be our last one. Determine if you can use the hypotenuse congruence theorem, hypotenuse leg congruence theorem to prove ABC congruent to DCB. If not, tell what else you need to know. Well, so far, I think about what's given to us. It says that AC is congruent to DB, so we have two congruent sides. Then we also have a pair of sides that are touching. Notice CB is touching itself for both triangles. So we have a hypotenuse and a leg on one triangle congruent to a hypotenuse and a leg on the other. So hypotenuse, leg, the only other thing we needed are these right triangles, and I would say yes, they are. So that means yes, the triangles are congruent by hypotenuse, leg. So these shortcuts, like I've said before, are going to be used quite a bit on proving theorems or doing proofs. So they're not going to go away. Let's do the best we can to learn these shortcuts so we can use them as much as we can. Have a good night.